Hi, and welcome back to the data science course. Continuing with the inferential statistics lecture series, we'll now learn about hypothesis testing. Hypothesis testing applies statistics on a sample to test an assumption about a population parameter. So basically, you're looking at your population parameters, made some assumptions about it. Now you need to test whether that assumption is true or not. And what it does, it uses the concept of proof by contradiction. What that means is that you prove a statement is true by assuming it is false. So if the assumption is proven to be false, then we can conclude that the original statement must be true. Okay, so slightly counterintuitive. What you're saying is to prove my statement is true, you assume that it is false. Now, what you do is check if the assumption is false. So if the assumption is false, that means your original statement is true, right? Because you assumed the statement is false, but that assumption is false, which means the statement is true, right? So it's a double negative basically. It's a very good concept and a very widely used technique in statistics and various fields. So it's good to learn this. Now, in hypothesis testing, you generally perform a sequence of steps. It's a very standard process. So let's understand that. What you do is you formulate the null and alternative hypothesis or the assumption. Now, what is the null hypothesis? It's the hypothesis that chance is responsible for the observations in the sample. Remember, you're using the sample to test the assumption about the population parameter. So, what the null hypothesis says is that chance is responsible for the observations in the sample, not the real value of the population parameter. So, that's the false statement. Now, the alternative hypothesis is that the observations in the sample are due to a real effect, which is basically what happens in the population. And it is, of course, contrary to the null hypothesis. So these are the two hypotheses which you have to formulate. They are generally in the form of a statement based on a test statistic. So what you do is you define a test statistic like mean, standard deviation, etc., to determine if your null hypothesis is true. So how do you test that hypothesis, right? You need to check some value against a certain condition. So for that, you determine a test statistic, and the condition would be the p-value. Now the p-value is nothing but a probability. So the way you calculate p-value for the null hypothesis is that you calculate the probability of seeing the apparent effect if the null hypothesis is true. So basically what you're calculating is the probability of occurrence of the null hypothesis condition in your sample data. It'll become clear when we show an example. Just follow the steps for now. So you've got the test statistic, you've got the p-value. Now you need to test this test statistics p-value or probability of occurrence against the significance level. So at what point do we determine that the null hypothesis is true or false? So you check it against a threshold, and that is called as the significance level. So it's between 0 and 1 because it's a probability, and it is the threshold below which the null hypothesis is rejected. So if you take the significance level as 0.05, it basically means it's a 5% significance. And if your p-value is less than or equal to alpha, you reject the null hypothesis and accept the alternative hypothesis. So the smaller the p-value, more the evidence that the null hypothesis is false. So basically, as the probability of occurrence of your null hypothesis condition gets smaller and smaller, the less chance it's going to occur, and more likely that your null hypothesis is wrong, and hence your alternative hypothesis is true or your original statement is true. So that's what this hypothesis testing is all about. I mean, you just have to follow these steps, determine the test statistic, then determine the probability, and finally the significance level. And this is again variable, so you can check 1%, 5%, 10%, whatever you feel is the right conditional value for your probability, below which you will reject your null hypothesis. Generally, 5% is a common value. Now, there are a couple of errors which you need to be aware of when you're performing null hypotheses. There are two types of errors, type 1 and type 2, and they occur because of wrong rejection of the null hypothesis depending on the p-value and the significance level used. So type 1 error is when you reject the true null hypothesis. So it's a false positive. Basically, you rejected the null hypothesis because it was false, but it's actually true. And that will be determined by the p-value and the significance level you used. Remember, this is selected by you or the system, or it's predefined. So definitely there can be inaccuracies. And that's why it's an iterative process. So you have to test different p-values against different significance levels to determine which is the ideal solution for you. Now, type 2 error is the opposite of type 1. So in this case, you're accepting a false null hypothesis. So it's a false negative. So basically, your null hypothesis is true. And so you accepted that, but in reality, it's false. So you should have rejected the null hypothesis, but instead you ended up accepting it. So that's why it's a false negative. So these are the two types of errors you should be aware of when you're performing your hypothesis testing. Now, the best way to understand this concept is through an example. It's slightly confusing because of this proof by contradiction concept. So let's look at that. Now, the example we are considering is the average annual returns of a multi-asset mutual fund over 20 years. So if you don't have a financial services background, a mutual fund is just an investment fund you'd put some money into, and that fund in this case is multi-asset, so it would have a composition of stocks, bonds, commodities, real estate, etc. And the portfolio manager of the mutual fund would manage the fund in terms of its composition, when to buy, when to sell, and you can buy a certain amount that fund with your money. And over a period of years, it will give you certain returns depending on how well it performs. So what we are considering is that the mutual fund is claiming that it makes at least 15% average annual returns during a 20-year period. So that's their claim. Now, the reason they're saying average annual returns is due to the fact that different asset classes and different markets give you gains and losses during different years. And a multi-asset mutual fund would equivalently give you good returns or losses in different years. So they try to smooth out and average out the returns to show you that if you held the funds units for a long time, you would eventually make a gain. So they try to paint a rosy picture of the fund's returns. But what we don't know is how bad it performs during worse years and how good it performs during good years. And is this claim true or not? So that's what we're trying to test. So the null hypothesis is that we assume that the mutual fund's claim is true, so the average annual returns are greater than or equal to 15%. So the alternative hypothesis would be that that claim is false. So the average annual returns of the fund are less than 15% over this 20-year period. Now, the test statistic we'll be using is the average or the mean of the annual returns of the fund, and we will calculate the p-value or the probability for multiple random samples of 5 years. So just remember this. We take 5 years out of these 20 years at random, and then we take multiple such 5-year samples. So it could be any combination of years, not in a sequence. And then we calculate the average annual returns for each such sample over 5-year period and check if it is greater than or equal to 15%. So what you've done is that out of your population of 20 years returns, you've taken a sample of 5 years and then calculated their average annual returns and checked if it is greater than or equal to 15%. And then you can test your p-value against a significance level of 5%. So p should be less than or equal to 0.05 to reject the null hypothesis. And if this condition is true, then you reject the null hypothesis and accept the alternative hypothesis, which means that the fund's claim is false, and that in fact the average annual returns are less than 15%. So hopefully this helps you understand the concept of hypothesis testing. So basically, all you've done is checked if a claim is true based on some assumption by taking a random sample from the overall population using a statistic like mean or average or standard deviation, etc., and tested it for a significance level like 5% or 10%. So basically, what you're saying is, what is the chance of this claim being true or false? And to test that, how comfortable are you in terms of the range of values for that statistic? Are you comfortable within a 5% chance of your test value, or 10% chance of that, or 20%? So it gives you a range, and then you can determine whether the claim is true or false. So how would you calculate this probability? It's reasonably straightforward. So let's say we took 10 random samples of 5 years out of these 20 years. You know, it could be any combination of years, as we've mentioned. Then for each such 5-year sample, you calculate the average annual return for that 5-year period. So what you have to do is calculate the return for each year in that 5-year period and take their average. And then for all of these samples, calculate the total number of such samples where the average annual return is greater than 15%, and then divided by the total number of samples, right? So very simple fractional calculation. That's generally how you would calculate the probability, which is the probability of occurrence of that particular event. In this case, sample average returns being greater than or equal to 15% divided by the total number of events, which is the 10 samples. Now you can check this probability, which is the total number of such true cases divided by the total number of samples, against the significance level of 5% of 0.05. Now this logic can then be extended to evaluate multiple mutual funds across multiple factors. So right now we looked at only one fund for 20 years for just their returns. Well, we could extend it and say, now I want to evaluate multiple such funds for multiple parameters like return, risk, portfolio composition, etc. Right? So you just don't want to know what the return was. You also want to know how much capital is at risk. Can they manage the risk in extreme market scenarios, or will they blow up the fund? So you have to assess those. Then you might also want to know what's inside the portfolio. Do they have any illiquid assets? Would they be able to sell them if required? So you can create multiple factors, and by using hypothesis testing, what you can do is iteratively using p-values and different significance levels, determine which is the best combination of evaluation parameters for multiple mutual funds. So what we end up doing is that we build a model to evaluate fund managers across relevant factors over a period of returns. So hopefully you now understand the statistical concept of hypothesis testing, what its uses are, how to do it, and then apply it in your own personal scenarios of testing different assumptions. With that, we'll end this lecture. Thank you.